Hi, everybody. Hi, Annalisa. Here's a look at some questions on that second page of the review for the final exam. And it begins off by talking about a conditional, and under what circumstances is a conditional considered false. And we've gone around and around about that, and I would tell you it must be a conditional is considered false when it has a true hypothesis leading to a false conclusion. That's when a conditional is considered false. It's strange that a false hypothesis leading to a false conclusion is considered true, but it is in a logic class. And then I go on to ask you, what would show this conditional to be false? If I paint the house, then it will look great. What would make that be a false conditional? And you have to say, well, it's when the hypothesis is true, I did paint the house, but the conclusion is not. It does not look great. So what would make this conditional false? If I did paint the house and it did not look great, then you'd say it's a false conditional. Which forms of a conditional are logically equivalent? And probably the note you'd like to make about that. A conditional looks like this. If P, then Q. And a conditional has a converse. How do you get the converse of a conditional? I'll switch the hypothesis and the conclusion. That'd be if Q, then P. And I ask you, are those logically equivalent? And no, heck no, they're not. A conditional is not logically equivalent with its converse. But a conditional also has an inverse. And how does one get an inverse of a conditional? Yeah, you don't switch them, but you do negate them. And if I were to negate the original conditional, it would say, if not P, then not Q. That's not the negation of that conditional. That's the inverse of that conditional. If I wanted to get the contrapositive, the only other form that I'm going to worry about, oh, wait a second, we can think of some more, but contrapositive, then I would switch them and negate them. It would be if not Q, then not P. And I would tell you which ones are logically equivalent. The conditional is logically equivalent with the contrapositive, and the contrapositive of the converse is the inverse, so they are logically equivalent as well. There is another form of a conditional. It's a biconditional. P, if and only if Q. And what's that logically equivalent with? If P, then Q, and if Q, then P. So we know some things that are logically equivalent with our conditionals. Give an example of the reflexive property of equality. If A is equal to A, anything equal to itself is the reflexive property. How about pi equal to pi? Which we know to be true. Anything equal to itself is an example of the reflexive property of equality. Reflexive property of congruence would have been like angle A is congruent with angle A. Give an example of the transitive property of equality. Easy enough to do that. If A is equal to B, you might begin with if, and B is equal to C, then what would the transitive property imply? That A is equal to C. What are the attributes of skew lines? And there's a few things we've talked about with skew lines before. They are non-coplanar. That's the main thing you want to know about skew lines. They are non-coplanar. There is no plane that holds them both. Could they intersect? No, they could not, because if they intersect, they would be coplanar. They must be non-intersecting. Intersecting. I know that skew lines cannot intersect. Could they be parallel? They don't intersect. Could they be parallel? No, because if they're parallel, they would be coplanar. They are not parallel. And if you know all those things about some lines, they must be skew. Thinking about some theorems we might have discussed before. If two angles A and B are complements of the same angle C, what must be true about angle A and angle B? Let me just think about this angle C over here. Let's say that could be 60 degrees. Let's let that be angle C. And angle A is its complement. Angle B is also the complement. What must be true about those? If these two angles are complements of the same angle, well, in this case, they'd both be 30, wouldn't they? And they would be congruent to each other. If two angles are complements of the same angle, then those two angles are congruent. Angle A is congruent with angle B. I think we can call that the congruent complements theorem. Two angles complements of the same angle, or congruent angles, would be congruent to each other. If two angles are congruent and supplementary, what more must be true? If angle A is congruent to angle B, that would force the measure of angle A to equal the measure of angle B. And angle A and B are supplementary, so you know that the measure of angle A plus the measure of angle B adds up to 180. What more must be true? If they're equal in measure and they add up to 180, those must be 90 each. They must be right angles. Right angles A, B. Use the sketch at right to find the measures of angle 1 and 2. And I'm looking at this sketch. And I've got a right angle here. And this triangle is shown to be isosceles. And these two angles, therefore, would be the base angles of that isosceles triangle, and they ought to be congruent with one another. Since 90 went there, they have 90 to share. They'd be 45 a pop, wouldn't they? 45 here and 45 there. Later we're going to work with this triangle, call it the 45, 45, 90. But for right now, it's just a 45-degree angles there and there. And this is also a 45-degree angle. You can tell that that's true because these are vertical angles. And I'm showing that this angle is 80 degrees, therefore its supplement would have been 100, because there's a linear pair. So inside of this triangle, I got 145. What does that leave for angle 2? I expect the angles to add up to 180. So I think that one's got to be 35. 35 and 45, there's 80, plus this 100, yep, there I got 180 inside of that triangle. So I could figure out those couple of angles. And then we got to know about the angles that are associated with parallel lines. There would be some corresponding angles in that picture. I'm just going to make a quick note about that for corresponding angles. Like that would be, for example, angle 1 and angle 5. They would be congruent, wouldn't they? And then there are alternate interior angles. And I can find a couple of alternate interior angles here. The only pair I can find are 3 and 5. And those would be congruent as well. How about some same-side interiors? Same-side interior angles. That would be an example like 2 and 5. Angle 2 and angle 5. And those would be supplementary. Maybe we could find some alternate exterior angles too, just for grins. Alternate exterior angles. For example, 4 and 6. And angle 4 would be congruent with angle 6. So there's lots of angles associated with parallel lines, and we just try to separate the ones I was thinking about. Then we're going to talk about slopes of lines. And what would be the slope of a line parallel to line L when line L has this equation? Well, I don't know the slope of line L yet, but I'm going to work on it for a second. I'm going to bring the 3x to the other side, leaving negative 2y equals negative 3x plus 10 divided through by negative 2 across the board, and we'll get that slope figured out. That would force me to think that would have to have been y equals, and a negative over negative is a positive 3 over 2x there, minus 5, because I had a 10 divided by a negative 2. So I know that this line has that equation. What would be the slope of a parallel? And a nice way to write that would be the slope of a parallel like this. And when lines are parallel, we know they have equal slopes. This slope was a positive 3 over 2. So a parallel line would have that slope. And it also asked me, what would be the slope of a perpendicular line to line L? And we can figure that one too, huh? The slope of a perpendicular line would be the negative reciprocal of the slope of this line L, and that negative reciprocal would be negative 2/3. And then it asked me, find the slope between a couple of points. I don't have a lot of room here, but let me just think about that. This point P over 8 and down 9 be somewhere about there. Let me put it P by that. And point Q would be left 4 and up none, somewhere about there. I'm going to show that line PQ because I think if I get a look at it ahead of time, I might not screw it up when I try to get its slope. Would you expect a slope to be positive or negative? I always think about that ahead of time. That slope's got to be negative, wouldn't it? And I'm going to hit it with the slope formula. You may remember the slope formula. I call it delta y over delta x. Change in y's over change in x's. Let's hit it with these couple of numbers. Negative 9 minus 0 over 8 minus negative 4. Therefore, negative 9 over positive 12. We ought to always reduce these fractions. That's a negative 3/4. So I wonder, does this line look like it might have had a slope of down 3 and over 4? I'm thinking, yeah, that's possible. Now I want to get the equation of that line. Anytime I'm looking for the equation of a line, I'm going to use the formula y minus y sub 1 equals m times x minus x sub 1. That is the tool that we'll be using this year to get the equation of a line. And I can take either one of those 2 points. I'm going to take the 8 comma negative 9. I suggest you take the negative 4 comma 0, and I'll use that same slope because I want the equation of that line. And the slope that we should use is negative 3/4. Let's see what comes. Y minus the y coordinate negative 9. That'd be y plus 9, wouldn't it? Equals negative 3/4 times x minus the x coordinate 8. Couple things to be careful here. I got y plus 9 equals, as I multiply through the parentheses, I get a negative 3/4 x. And here I'll have a negative times a negative, therefore a positive, and we got to figure out what 3/4 of 8 is, huh? That's pretty easy. That'd be 3 times 8 is 24. Over 4 times 1 is just 4, so 24 divided by 4 is just 6. Yeah, 3/4 of 8 would have been 6, and a negative times a negative is a positive 6 there. So now let me subtract 9 from both sides, and I got y equals negative 3/4 x minus 3. And let's just look back at that graph and see if that seems like it could have been correct. Yeah, I'm thinking that could have been the equation of this line when we graphed it before.